Hello, very good morning. So we are back in this particular model, and now we're gonna see how we can uh, redesign this particular part. So the whole part looks has a basic shape of an extrude. So now you can show your reference planes by clicking in this area in the model tree, and you can expand the reference planes by clicking on this plus toggle. So I can expand and I can contract by clicking it. And let's hide the front, top, and the right plane. So now we show our mesh and we hide the individual front, top, and right planes, but we still have the reference planes turned on. This is done so that we see the other planes that we're creating, but we hide the default front, top, and right planes. Now, the first step we are going to learn is how to create a plane. So here we can go in the model tab where you see my cursor. That's the place where you have to click to activate or go to a current tab. So you can go to model tab. So click on model tab and you will see a set of tools here like create solid. Some of them are grayed out like extrude, revolve, loft, sweep. It's grayed out because in DXGo, in order to create an extrude body, you need a sketch, which we have not yet made, so it's grayed out. But here we have the reference geometries like planes, vectors, points, etc. So these are our construction geometries. So these are open, they're not grayed out, which means that you can use them. So you can click on where it says plane. And the moment you click a tool in Geomagic Design X, it will open a widget that looks like this. This widget will contain all the selections that you need in order to make your plane. So if for any tool, if you do not know what it does, so here in Design X Go, I clicked on Add Plane and I don't know what it does. So you can click F1 on your keyboard and it will automatically go into the help documentation. So I clicked F1 and you can see that it took me to the help documentation of the plane tool. It is supported in DXGo Plus and Pro, and below it mentions what it does. It creates a plane of an infinite size, and the reference plane is useful for sketching as a sketch plane, is used for cutting bodies with a plane, creating mirrored features, finding the middle plane of a symmetric mesh, etc. And if you scroll down below, it will describe in detail how to use this particular tool, different options like how to extract a sketch plane from a mesh, and it goes and explains each of the options present in detail. So the options in detail, it says what are each of these methods, and if I want to see how to understand extract method, I click on extract and it takes you to the definition. It says extract a plane from selected entities using a fitting algorithm. It also describes in detail what it means by a fitting type, what method is used for doing the fitting, and it shows further details on cleaning, removing outliers, etc. So for any tool, you can click F1 on your keyboard and it would automatically go to the help documentation. So now here it's asking for some entities. It's shown in a yellow color here. It's got a yellow border around this area where it says entities. And here when you hit the method, you have a wide variety of methods to create planes. So you have extract, which is the most commonly used method to extract a plane from a set of points. You have projection, pick multiple points, pick a point and a normal axis, orthogonal planes, draw a line, mirror, etc. So you can change this to extract. So the extract method is where we are going to extract a plane. So you can go and make your selection. You can choose either the rectangular selection mode, and you can make a selection like this. So you can add to your selection by hitting Shift on your keyboard. So you can select a good amount of this particular data. So you can extract a plane, and the plane you want to extract will pass through all these points. So you can choose a sufficient number of points. So I'm clicking here on extract. I'm holding Shift on my keyboard to add to my selections. Now, when you made the selection, you can see that over here it says polyfaces of 1 underscore basic underscore part, which are these triangles that are selected. Now, if you come down below to fitting options, here you see there are 3 methods: best fit, which produces a best fit plane. You have min bound, which produces a plane that goes through the minimum or the lowermost point, and max bound, which produces a plane that goes through the maximum point or the topmost point. And here you have a remove outlier. So this tool is like a filtering agent which removes outlier points. So you can use an in-sigma method. I have it currently set to 3, but you can change the values appropriately. And you also have filter with ratio and filter with distance. So you can choose the appropriate filter methods, and I'm keeping it at in-sigma. And now, if you want to preview this particular plane, you can click on where it says preview. So where you see my cursor, there's like a magnifying glass. So you can click on preview. And if you zoom in, you'll see that the software has found a best fit plane passing through the points that you have selected. So if you zoom in a bit, you'll be able to see all these points shaded in a turquoise color, and your plane that you're making will be shown in a orange color like this. So where you see the cursor going, that's how your plane is looking like. And if this looks good, you can say accept, and you can come out of the plane tool by clicking on cancel here. And you can see that there is a plane 1 added in your model tree. So in the top model tree, you have plane 1 here, and you have the plane 1 in the bottom model tree here. So if you want to hide it, you can hide it. And if you want to show it again, you can click toggle here to show it again. So this is how you can extract a best fit plane. You can practice this one more time, and this time you can select the Smart Selector button here. So you can select the Smart Selector selection icon where you see my cursor. And for now, I'm going to select this particular face, and I'm going to select that particular, the polygons in this top face like this. So you can go back after you have made your selection as well. Go into the plane tool. You can ensure that the method is in extract, the fitting type is in best fit, and then you can say okay. So this will make another plane for you, plane 2. This is how you can best fit and extract planes. Now, if you want a plane through the topmost point of this particular block, you can do that as well. So you can select, say, the rectangular selection mode here. And here, instead of visible only, you can change it to select through. So you can click and toggle this here by placing and clicking on this visible only toggle that you see on the screen. And I'm going to make a drag box around this particular area of the sphere. So I select this area of the sphere, and I can see that I have selected that particular sphere. Now, if I want to fit a plane that goes through the top, I can click on plane, and now the polygons are already pre-selected. And instead of best fit, you can click on max bound. So now you can select max bound here instead of best fit, and you can select view the preview. Now, as you can see, it made a preview of the points that go through the topmost point of your selection, which is the top point of the sphere. It shows it in a preview. And if you want, you can accept that plane, but you can also go back into restore. And if you try min bound and do a preview again, it will show the plane that goes through the minimum point of your selection. The bottommost point of the selection would be used, and those would be best fit to form your minimum bound plane. We can go back here again. I'm going to put it back into max bound. And now you have your max bound plane. Now, in your max bound plane, you can go back again and you can add an axis constraint. So here where you see the screen, there's an option called constraint options. So if you want to extract the maximum plane, and if you want it parallel to, let us say, plane 1 or plane 2, you can select axis constraint. And once you open the check mark, you will have some options here. So you can use specific direction as initial guess, or you can say use specific direction as it is. And it asks for a direction. So you can hover your mouse over, let us say, plane 2. And you click on plane 2, and it will add plane 2 for this direction. Now you will be able to see that it makes the max bound point across your selection, but the selection made, the plane made, would be parallel to plane 2. And you can say, okay, so here you have plane 1, 2, and plane 3. So in plane 1 and 2, we use the best fitting methods, and in plane 3, we use the max bound fitting, and we made it parallel to plane 2 so that we have the topmost point of the sphere, and it's also parallel to plane 2. In order to hide these planes, you can come into your model tree where you see the cursor, and you can click and toggle them off and on, and those planes would be hidden. This same method can be used for extracting vectors. So you see close to the plane tool in the model tab, there is a vector tool. So you can click on vector. So when you click on vector, it would open up this add vector widget. This widget, like in all the tools in DesignX Go, you have to make your selections here. If you want to learn about this tool, you can click on F1, and automatically the help documentation on how to use the vector will be present here. It would define what a vector is and explain the options in detail below. So here, if I click on the method dropdown, there are a lot of methods: extract, find slot axis, find cylinder axis, find cone axis, etc. So you can click on something like find cylinder axis and come over here, and you can select the triangles in the face of this cylinder. So I can select them by clicking on the smart selector. So please click on the smart selector, click grow your selection to select the appropriate number of triangles. So as you can see, I have the entire internal face selected this way, and I have the fitting type as best fit. Now if I want to take a preview, I can take a preview, and the software will show me a preview of the vector in an orange color. And if it looks good, you can say accept, which is this check mark, and the software will add vector 1 in your model tree. Now you can always click and rename these objects. So I can click and rename it as cylindrical vector, like that. Now if I want to extract this particular cone axis, I can also select, I have the selection icon on smart selector here. I select the internal triangles of this conical face, and then you can go here in the model tab, you see the vector option, click on vector. Now you can see that it has the polyfaces of the one basic part already selected, since you selected it before you clicked on vector. Now you can change the method to find cone axis, and you can take a preview, and the software will find the cone axis on of the cone that goes through all these points which you selected, and you can say okay. So here we have made our conical vector that looks like this, vector 1. You can also rename this by right clicking and say conical underscore vector. Now if we want to edit this vector, so we made planes 1, 2, 3, and we made a cylindrical vector and a conical vector. Now you can show your base plane, which is plane 1, by clicking here, and you can see that you have this base plane. Now if you want to make this conical vector perpendicular to this base plane, you can go to conical vector here on the model tree where you see my screen. You can make a right click, and when you make a right click, you will have a button called edit, so you can click on edit. Now everything looks correct here, so it's asking for entities, so you can come here and select the points on that internal face is on best fit method. Now the same way we did previously, we have to click axis constraint, so you can click on axis constraint and you can change the radio button to use specific direction as it is. So we want to extract the axis of that cone, so we can change the method to find cone axis, and we also want it to be perpendicular to the base plane, so you can select in that where it says direction, you can select plane 1 from your model tree. You can also go to the line selector mode and select this particular plane here. So the operations is very simple. We go to entities, we pick this particular faces, and here in axis constraint for the direction, we choose direction and we select plane 1. So now it's going to make a vector that would be the axis of the cone, and it will also maintain a perpendicular relationship with the base plane that we chose, which is plane 1. So this is how you can extract vectors, cylindrical vectors, conical vectors, symmetric vectors, etc. by using Geomagic Design X Go. Now that we extracted some planes and some vectors, we can look in this model and we can see that it's pretty much like a single shape. It's like a rectangular shape with a filleted edge and an extrude. We got the base shape of this particular plane, the base plane, plane 1. Now, in order to make a sketch, you can go into the sketch tab. So in the sketch tab, in the very right, if you click this drop down where you see my cursor, there will be two options. One is mesh sketch and the another one is a regular sketch. Regular sketch is the same as in CAD, where you can make a sketch on a plane. But when it comes to using the scan data, you can select the first option, which is mesh sketch. So let's click on mesh sketch, and when you click on it, it is going to show you a widget, as you can see on the screen here. So the radio button is in planar method, so we are going to sketch on this plane. And here you can see that there's a box which says base plane, and it's asking for the plane in which you want to make the sketch. So you can move your screen and pick plane 1 by left clicking on plane 1, or you can also pick it from the model tree. And if you want to remove this selection, say you made a mistake, you can always click here on plane 1 and hit delete on your keyboard. That would remove the selection that you made. So if you wanted to use plane 1 now, you can hover your mouse close to plane 1 and it would highlight in a red color, as you can see on the screen, and you can click OK. Now, when we click OK, we see that there is a small turquoise colored preview. You can click on this particular rectangle and increase the size. You can click and drag and move it. So you can move it and position wherever you want it. So I'm increasing it so that I cover the entire size of this particular model. Now we can see that we have a trace, but the trace does not look good. It does not look correct. So the turquoise colored preview is the trace of the cross section between the plane and the mesh. And you also see two arrows. You see a thick blue arrow here, which is the silhouette arrow, and a thin blue arrow here, which is the offset arrow. So if you want to offset this cross section, you can click, hold, and move it up. So you can move it and place it where you feel fit. So here I'm offsetting at a height of 30 or 27 mm. You can see that the plane cuts this way, and wherever the plane cuts the scan, it shows you that particular cross section. And since we want to make the base, I'm going to move it slightly above. So here I'm moving it 3 mm with an offset. Now when I do that, I can see that my offset looks clean and crisp. So you can also add a distance by typing here. So if I had it at 0 mm, which was the default, this is how my cross-section plane is cutting with the scan. This is not useful information for you to sketch on. So you can also move it up slightly by using this tool here, or you can type in a value, say offset 2 mm above. And when you offset 2 mm above, the software in the background will offset a plane by 2 millimeters and show you the cross section going through that plane. Now we can see that this is a pretty crisp preview. It looks good and contains all the information that we need. At this stage, you can say OK by clicking the check mark here. So when you click on OK, you'll see that the software has opened a sketch palette. So here you have the sketch palette with all the basic sketching tools like line, rectangle, slot, circle, arc, etc. And you also have your body and trace here. So you can hide the mesh by clicking here where you see my cursor. So you toggle this on, it'll hide the mesh. You toggle it again, it'll show the mesh. So you can hide the mesh and see that there is a pink colored trace. So this trace is basically a cross section that goes 2 mm away from the base plane. You took the cross section and the cross section is projected onto the sketch plane. So we get a very crisp cross section of this particular body. This is what we call a polyline in Geomagic Design X. And here we have our sketch elements. So since we have the trace of this particular body, we can start making this particular sketch. So here we have the line tool. So you can make a single click on where it says line. And you can see that some areas are highlighted in a dark pink, like a solid pink. So here in this area, if you see, it's highlighted in a solid pink. And here in this area, it's highlighted in a dotted pink. So if it's highlighted in a solid pink, it means that the software identifies this segment as a straight line. It identifies this segment as a straight line. That's why it's solid. When you come here, it's dotted because the software clearly identifies this as an arc or a circle. So here we have the fit polyline checked on. So you can hover on top of a particular line and you can just double click and you can see that it has produced a best fit line. So it's very easy. You can hover over the line that you want to best fit and do a double click. Hover over, it turns yellow, double click. hover over, double click. And if you want to come out of the line tool, you can either hit escape on your keyboard or hit the check mark. So here we've made 4 lines, and if we want to remove these lines, you can make a drag box selection and hit delete on your keyboard. So I'm going to show this again. So we have our trace, and if we want to best fit lines, we can click on the line tool, hover over the mouse, and double click. Hover here again, double click. When you hover, it'll show in a yellow color, and do a double click. And the same process here again, double click. Now, if you want to extract an average, you can do a single click. So you can do a single click here and do another single click here. Now, the software, when you do a single click, it creates a best fit across the selections. That's why it made this as a center line between these 2 lines. So we can hit escape. Now, if we do select line 1 and select line with a 2 with a single click, it'll make a best fit line between these 2 segments, which is not something that we need. So you can click on line, hover, double click to make a best fit line. Like that. The same method applies for arcs, so you can hit escape and come out of the line tool. So when you hit escape, this widget would not be there, which would indicate that you're out of the line tool. So I hit escape on my keyboard, I'm out of the line tool. Now we have something called 3-point arc here right below the line tool. So you can click on the 3-point arc, and now you'll see that this is highlighted in a solid color. So you can best fit, if you want to best fit an arc, you can hover over, it would turn yellow, double click. Likewise, you can come to this side, you can hover over this particular area and do a double click. And hence, you can make your orders. Then once you're done, you can say OK here. And the same functions apply for things like circles. So you can go to the circle tool. You want to make a best fit circle. You come here, you hover your mouse over that particular trace and do a double click. And automatically it will best fit a particular circle for you. Now that we have seen how we can make a best fit line, one thing we need to do is apply constraints. So here you can right click on this line and you'll automatically see that there are some constraints, like make it horizontal, make this line vertical, make this line fixed, make this line into a construction line, etc. So you can say make it horizontal or make this line vertical, and the line would add a constraint here that you can see. So you can make this line vertical by making a right click on this line, which would open this widget, and you can say add it as vertical. So you can do the same here. You can right click and say make this line horizontal, and it will add that particular constraint. So please practice it by doing so. And if you want to remove a constraint, you can just hover over that constraint symbol. So as you can see here, this constraint box is initially in green. When I hover my mouse, it turns red. So you can make a single click on your keyboard, on your mouse, and then do a delete. And when you do that, it would remove that constraint. So I want to remove this constraint, single click, delete. Hover my mouse over that constraint, click, delete. Hover my mouse, it turns red, single click, and delete. So that's how you can add horizontal and vertical constraints. You can also select items. So you can select line 1, hold Control or Shift and select line 2. So you can select 2 lines like this. And if you want to make them parallel, you can go here to Constraints, where you see my cursor. This Constraints tool lets you add or edit constraints to the selected items. So here you can click on constraints and you get all these boxes which says horizontal to make both of them horizontal, vertical to make both of them vertical, coincidence, perpendicular, parallel, equal length, etc. So here you can click on parallel, and when you click on parallel, it would add parallel here and show the constraint symbols on both of these lines. And you can say, okay. Likewise, you can do this for these two lines. So again, click on line 1. When it is selected, it shows it in a turquoise color. Hold Control or Shift, either works, and select line 2. Now both of these lines are selected and they're shown in a turquoise color. And you can go to Constraints, where you see my cursor, and then make them parallel and say OK. You can also use this method to add other types of constraints. So you can say, hold this line, click on line 1, and then select this arc as well. Click Select. Now both of them are selected. I selected line 1 here. Click. Now here I am holding Shift or Control and then making another left click. I selected both of them. So I can go to Constraints and say make them tangent. So this is going to apply a tangential constraint between this line and this arc. And you can repeat this process again. So click on the arc, select the second line, go to Constraints here in the top and say make them tangent. And it will add the tangency conditions. So let's practice it again. Select line 1 and select arc. Both of them are selected. Go to Constraints, make them tangent. Select this arc, select this line, go to Constraints and make them tangent. So you can add your constraints appropriately. Now if you want to make these two arcs have equal radius, you can select these arcs, go to Constraints, and you'll see that only those constraints would be present. You can say make them have equal radius and say OK. Now it will have those items present. Now if you zoom in on this particular area, you will see that these 2 points are not connected to each other. So in order to make an extrusion or make this sketch be extrudable, you have to have it closed. So one option is you can definitely click and hold on this vertex, and you can move and hover on top of this other vertex and it will show a coincidence icon, and you can leave it there. Now this is not a very nice way to do it. So if you want to revert the change, you can go to undo. But basically you can click, hold this point and move this particular sketch and hover it on top and drop it like that. This is approach 1. And if you want to see these disconnected edges clearly, you can go here in the Accuracy Analyzer tab. So towards the right, you have the Accuracy Analyzer. Click on Accuracy Analyzer tab. So here in the bottom, there's a check mark for disjoint ends. So you can click on disjoint ends and it would highlight the disconnected edges in a green color, as you can see on the screen. So wherever you have disconnected vertices, you'll see them in a green color. As you can, they'll be highlighted in a green color. So it's in the Accuracy Analyzer tab. Here, disjoint ends. This is where you can find that particular option. Now, in order to extend and trim these two lines without changing the direction, you can use the trim tool. So in the sketch, you have the trim option. So if you click on the trim tool, it'll provide you with two options, power trim and corner trim. So you can, the power trim is to chop features that you don't need, the unwanted areas. So you can change it to corner trim. And here you can click on line 1 and then hover your mouse on line 2. So these are the two lines that you want to extend and trim. So you selected line 1, hover your mouse over line 2. It would show you a preview in yellow. If it looks good, make a single click. Now you'll see that this particular green vertex that you had here is gone, and these two lines are extended and connected. That's why you see it in a dark blue color. You can do the same operation here. So you have a line and this arc. So you have the radio button on corner trim. So click on this line, hover your mouse over the arc, and say OK. Likewise, click on arc, hover your mouse on the second segment. The preview is shown in yellow. If it looks good, make a click. So here you can practice extend and trim. These two lines, as you can see, are disconnected. So click on line 1, click on line 2 to trim them together. So likewise, you can trim all these ends as needed. And you can see that the outer surface now does not have any disconnected points. We only have disconnected points in this inner rectangle, which you can trim and close accordingly. So this is how you can trim and close unconnected or disjoint ends without clicking and holding the line and moving it. This ensures that you are not essentially changing the direction of the two lines. You're extending them in the direction they have, and likewise you're connecting them by using the corner trim tool. And like in other tools, once you're done, you can either come out of the trim tool. You see the widget here, which means you're in the trim tool. So if you want to make a line, it'll then go to the line tool. But you can also hit escape and come out of the tools by doing this. Now that we have made the sketch here, we have this option called Smart Dimension in Geomagic Design X. So you can click on Smart Dimension, and it works pretty much the same way as in CAD. So you can click line and select this other parallel line, and you can drop it here. So from the sketch that we made using the scan, the dimension came as 200.6214 millimeters. Likewise, if you wanted to measure this height, you can make a single click here and another click on this line, and the software will measure the distance between these two lines. Same thing for radius. Click on the radius of this particular circle and drop it. Click on the radius of this arc and drop it here, like that. So this is how you can dimension this particular sketches in DXGo. And if you want to edit this value, you can double click and say change it to 30. So it's a nice whole number. You can change this to 200 by double clicking and changing it to 200. You can add 30 here, and this is 99.6. If you want to change it to 100, you can change the dimensions and enforce your constraints, as you can see here. So this is how you can perform dimensioning in Geomagic Design X. It functions the same way as in CAD softwares. So you can click and try and move these tools. And as you can see, the sketch would change and update accordingly. Say, for example, you have this cylinder. You can click and move it around because it's unconstrained. You can always make a center line here. So you can click the line drop down and it will show the center line tool. And here in the origin, you can click and make your primary axis like that. This is your horizontal and vertical axis like this. And now, if you hold this particular circle and place it on top of this particular point, you can see that the line has turned black because it's fully constrained. Likewise, you can make a dimension from this line to this line. You can also make this line and this line parallel. So you can keep on adding your dimensions and it will start to constrain the sketch more and more. So now you'll be able to move it only in this particular direction. You can do this again by adding another constraint here and making a dimension between these two lines. So now you can see that the sketch is completely dark, which means that it's immovable. Everything is constrained and in the right position. And after you have made your sketch, you don't need to make it fully constrained, but you can see here there's an exit button. You can click on it. So when you click on apply and exit, you're going to come out, and here you have sketch 1 in your model tree. So this is how we can perform sketching in Geomagic Design X. We saw how we can best fit and use the features to develop and extract best fit planes like plane 1, 2, and 3. We also saw how we can extract vectors like a cylindrical vector, a conical vector, and provide constraints by making it perpendicular to your base plane. And we also saw how we can extract those cross sections and develop your sketch. So now that we have made this sketch, you can use this sketch to make an extrusion. So you can go to the model tab, and here you can see that there are options that are open now. So you see that there's an extrude option that's open, revolve, loft, sweep. These options were previously grayed out, but now you can click on extrude and you can select on the sketch. It shows this widget. You can select sketch 1 and you can see that you can extrude up to the distance that you need by clicking on this blue icon or blue arrow. You can move it to the distance that you need, and you can place it where you feel comfortable and say okay, and it makes your first solid.